All right, welcome. So today, or this unit, we're going to be solving quadratics. So in our last unit, we did a lot of factoring, okay? Factoring quadratics. And now we're going to learn how to solve them, all right? And I know you've solved equations before, like linear equations. Now we're going to do it with quadratics. So here's our calendar, everything that we're going to be covering. Please note that Wednesdays you need to check on Canvas for any assignments. I have it. What my plan is that I will have quizzes on Wednesdays that will go over maybe 10 problems at the most that will go over the lessons that we did in the past. So like between here and here, if I can get my pen, okay, this is going to be a Wednesday between lesson 2 and 3. So I'll probably have some sort of quiz or questions for you to do about using those 2 lessons, okay? So please make sure you stay caught up so you don't lose points. All right, we have 2 reviews, and we're just going to see how it goes. One of those days is going to be a minimal day. So I think if it's the A day, I think you're going to miss some time. So just keep that in mind, and I'll figure out more or less what we'll do for those reviews. Okay? All right, so again, if you haven't learned how to factor, we're still factoring. So please, if you need to stay after school and get some help, I'm here for you, okay? All right, so because first thing we're going to talk about is solving by factoring. We have to factor if you want to be able to solve these problems. All right, so first off, what does it mean to solve an equation? All right, what does it mean to solve an equation? Okay, so like we mentioned before, you've solved linear equations. If it was something like solving an equation, something, I don't know, it could be something like 2x plus 5 or something like equals 3. Okay, if you were to solve that equation, you would need to get x by itself. So you would subtract 5 from both sides. That would give us a negative 2 is equal to 2x, and then we'd divide both sides by 2. And you'd end up getting x is equal to negative 1. So that is a solution for a linear equation, okay? And we're going to be doing it the same, or something similar with quadratics, okay? So we're just going to need to solve for x. All right? One thing we need to talk about is the fundamental theorem of algebra. Okay, the fundamental theorem of algebra means that a polynomial of a degree n, okay, it could be any number, okay, has n solutions. All right? So like, for example, if you had a linear equation, like we just did, there was one solution. If we have an equation that's something like x squared plus 2x minus 1 is equal to 0, this is an equation, it's a quadratic equation, and since its degree is 2, then there is going to be 2 solutions. Okay? Or if we had another crazy number, like maybe x to the 9, 3x to the 9, plus 2x to the 7th minus x equal to 0. Okay, since the degree is 6, there is 6 solutions. Thank goodness we don't have to do that, right? At least we're just doing 2 solutions. All right, so that's what the fundamental theorem of algebra tells us. All right, and I'll have some questions on that, I think, on the homework, and just make sure you understand what that's meaning, the fundamental theorem of algebra. So this unit, we will be solving quadratics, meaning we have x squareds, okay, quadratic equations. how many solutions will all of your equations have? So here is the key. I guess we already did it right here. There's going to be 2 solutions. Always. Okay, always 2 solutions. Okay, those 2 solutions could be the same, but there's always going to be 2 solutions. All right, so before we get into any like solving, let's just do a quick reminder of how to factor. So these ones are not equations. These are expressions. And again, if I set that equal, put an equal sign like that, that would be an equation where we could solve. But here, this is just an expression, and we can't solve it, but we can sure factor it. All right. So again, factoring. First, we always want to see if it's in standard form, and we want to take out the GCF. So for A, it's already in standard form. We have the highest down to the lowest exponents. Okay, and then there's no greatest common factor. We can't take out a P. We can't take out a number, okay, that we could divide all 3 of them by. So then we go and do our glasses. So we will do glasses. That gives us 9p squared, and it needs to add up to give us the middle term. Okay, so something like maybe 9 and 1, but both of them may be negative. Okay, if we multiply those, that gives us 9p squared, and if we add that, gives us the negative 10p. All right, since a is 1, we can use a shortcut. We could just do p minus 1 and p minus 9. Okay, again, if you wanted to do grouping, you're welcome to. Okay, here's another example. Pause for any of these, give these a try, okay? This should just be a review. All right, so here, it's standard form, check. Greatest common factor, looks like we can take out a 2. Uh, 54 divided by 2, is that 27? Yeah, 27. Okay, so we factored out a 2, divided everything by 2. Okay, and then we'll do glasses. So negative 27b squared. It needs to add up to give us a negative 6b. So for 27, only choices are 1 and 27. 2 doesn't go, 3 does, 3 and 9. 4 doesn't, 5 doesn't. Looks like 3 and 9 is going to work for us. So we'd need to do something like negative 9b and a positive 3b. Okay, since we took out the GCF, a here is 1, so we can use the shortcut. We'd do 2 times b minus 9 and b plus 3. Okay, if this, again, if you haven't gotten factoring yet, you may need to go back to the videos for the last unit, or come and talk to me. Get some help. All right, okay, this is the difference of squares. So we can easily come up with n plus 9 and n minus 9. If you wanted to do glasses, you still could. You could multiply those together. You'd get negative 81n squared, and it would need to add up to give us 0n. The only way to get that would be something like 9n minus 9n. Okay, and you would plug that in. You could use the shortcut. And then D, last but not least, okay, no greatest common factor. It's already in standard form, so we'd need to do glasses. Negative 6x squared adds up to give us 5x. Something like 2 and 3. So like, no, that wouldn't work, because if you did 2x, if you had it, they'd both need to be, one need to be positive. That wouldn't work, okay? So we would need to do something else, something like 6x minus 1x. That would work. That gives us 5x, and if we multiply, it gives us negative 6x squared. So can we use the shortcut? No, because a is 2. So we'd need to substitute that middle term in. So 5x is equal to 6x minus 1x. And then we'd need to do grouping. So greatest common factor for the left side would be 2x. That leaves us with x plus 3. And on this side, it looks like we could factor out a negative 1, x plus 3. Okay, so this is our common factor that we can take out, x plus 3. And that leaves us with 2x minus 1. All right, so that's basically, in a nutshell, everything we covered. Yeah, that's about it. Okay, so questions, let me know. All right, let's talk about the zero product property. Okay, this is important. This is important. Okay, so let's start with this. If A times B is equal to 0, then what do we know about A or B? Okay, how could you get 0? What do you know? What would you need to know about A or B? Well, either A is 0 or B is equal to 0, or both. Okay, so we're going to use this to solve quadratics. Okay, because this is very similar. We have a term here, and we have a term here. Okay, this could be like our A times B is equal to 0. Okay, so that means that 2x, either 2x minus 1 is equal to 0, because that would have to, if that is 0, then that doesn't matter what the right parenthesis is. Okay, and then either that or x plus 3 has got to be 0. So if one of those parentheses is equal to 0, then the whole thing is 0. So that is the zero property, or zero product property. Okay, if we multiply two things together and it gives you a 0, one of them has to be 0. Okay, so to solve that, all we need to do is add 1. I didn't want to do that color. Would add 1 to both sides, and then would divide both sides by 2. And we'd get x equals 1/2. But wait, since it's a quadratic, the power is 2, we have two solutions. Here would be the other solution. We'd subtract 3 from both sides, and we'd get x is equal to negative 3. So we have two solutions. Our solutions here would be x is equal to 1/2, comma, negative 3. And it's not an ordered pair, it's just a list of solutions. So don't do parentheses. All right, so we want to solve each of these problems. Okay, I think these are ones that we did above. So kind of for the sake of time, we will start with just our solution. So here we have A, this is the same problem here, so that was P minus 1, P minus 9 is equal to 0. And over here, we did this one right here. So that is n plus 9 and n minus 9. Okay, so if I ask you to solve a quadratic like this by factoring, you'll do what we did above, and then this is the last step, is to solve. Okay, so again, using the zero product property, either this is 0 or this is equal to 0. So P minus 1 is equal to 0, or P minus 9 is equal to 0. So here we will add 1 to both sides, and we get P is equal to 1, or if we add 9 to both sides, we get P is equal to 9. So our solution will be P is equal to 1 comma 9. All right? So write down your solution here for this equation. All right, so here we set either n plus 9 must be equal to 0, or n minus 9 is equal to 0. So we would subtract 9 to both sides, we get n is equal to negative 9, or n is equal to positive 9. All right, so let's bring it all together, okay? We'll start with the equation, we'll factor, and we'll solve. So again, before you begin solving, one side must be equal to 0, okay? It has to be in standard form, okay? So that what standard form again is ax squared plus bx plus c is equal to 0. All right, where a, b, and c are just the coefficients and the constant. All right, so here we go. Is this in standard form? Check. Everything is on the left side. Check. We have 0 on the other. Check. We're good. Okay, so we will do glasses. Here we'd end up getting 14k squared. It needs to add up to give us 9k. So what makes that work? Maybe 2 and 7. So 2k plus 7k. Here we can use the shortcut because a is 1. So we're going to have our two parentheses, k plus 2, k plus 7 is equal to 0. And we'll use the product, zero product property, okay? Okay, so we'll have k plus 2 is equal to 0, or k plus 7 has got to be equal to 0. Because again, if this is 0, well, let's just do this, okay? So that ends up giving us k is equal to negative 2, or k is negative 7. Okay, so again, we can check. We can plug those in. If we did k is equal to negative 2, what would get would be negative 2 plus 2 times negative 2 plus 7. That gives us 0 times 5, which gives us 0. So we have, it's correct, that is a solution. Okay, we could try it with the other one. We could do k is negative 7, so negative 7 plus 2 times negative 7 plus 7. Well, this gets 0. So that means that the whole thing is 0. Okay, because 0 times anything is 0. So we can always check our solutions that way. And I would suggest doing that. Okay, let's try this one together. Again, GCF first. So here we have a leading negative. We need to take that out, or else you're going to get something wrong. So please take it out. Change all your signs. And then we'll just do our glasses. So 4x squared, it needs to add up to give us 4x. That would have to be 2x plus 2x. Since we took out that negative, we can use the shortcut. So we'll have x plus 2 and x plus 2, right, is equal to 0. We'll use our 0 product property, which tells us that whatever's in this parenthesis has to be equal to 0, or the other parenthesis has got to be 0. And for this one, you'll end up getting x is equal to negative 2 and a negative 2. Okay, so here we have two solutions. They just so happen to be the same. Okay? All right. So before I let you go and try and do some of these problems, let's just do a quick review of what's going on. So first, solving by factoring, we need to move all the terms to the left, okay, using plus or minus. We haven't done any of those, but look at D. Here we have a 3 on that side. We need to get it over first before we do anything else. We can't use factoring if we don't have everything on one side, okay? Then we're going to factor the equation completely greatest common factor first. Set up the factors, or set each factor equal to 0 and solve for x. So that's what we did here. Okay, and then we'll just list our solutions, and we got it set. Okay, all right. So here is an example where it's not all on one side. We'd need to add 2 to both sides. We want to check for greatest common factor. If not, we'd go straight into glasses. 12k squared needs to multiply to give us 7k. What would make that work? So you could do 1 and 12, or 2 and 6, or 3 and 4. Looks like 3 and 4 would work great. So 3k plus 4k, and if we multiply it, gives us the 12. Okay, can we use the shortcut? No, because a is 6. So we'd need to use grouping. So we'll substitute that in for the middle term. So 3k plus 4k, which gives us 7k plus 2. We'll do grouping. So it looks like we can factor out 3k, and that leaves us with 2k plus 1. And greatest common factor for this side looks like we could take out a 2, and that leaves us with a 2k plus 1. Right? So again, this is our common factor we can bring out, and leaves us with 3k plus 2. And again, now we have it fully factored. We're just going to need to use our 0 product property. Okay, I always forget that. Okay, so again, we know that either 2k plus 1 has got to be 0, or 3k plus 2 has got to be 0. So if we solve, we'd subtract 1 from both sides. 2k equals -1, and then we'll divide both sides by 2. So one of our solutions is -1/2, and then here 3k equals -2. Divide both sides by 3, and our other solution is -2/3. So we'd write them. K is equal to -1/2, comma, -2/3. Okay, so please, I know you got the answers here. I want you to write them like that so that I can easily see. All right, so I'd like you to try a couple of these, maybe these next 3, see what you come up with. All right, hopefully you give it a try again. Please, you'll learn it a lot better if you try and do it, even if you get it wrong. So we'll subtract 3 from both sides. That gives us x squared minus 25 is equal to 0. This is the difference of squares. You could do glasses, but you could also just do the difference of squares. So x plus 5 and x minus 5. Okay, and then we'll use the 0 product property. So x plus 5 is equal to 0, or x has got to be, x minus 5 has got to be equal to 0. So here we'll subtract 5 from both sides, and we'll add 5 from both sides. To get x by itself, we'll get x is equal to -5 and a positive 5. Okay, all right. Give this one a try if you haven't yet, because this is kind of like we did above where you have to do grouping. I want to make sure you're good with that. So this is already in standard form. Everything's on the left side already. Okay, we can't take out a 2. So we know here that a is 2. We can't use the shortcut. So we'll do glasses. -18x squared has got to equal -17x. All right, so that's got to give us like a -18x plus 1x. Okay, that should work. We'll plug all that in, so 2x squared minus 18x plus 1x minus 9. And then we'll do our grouping. So we can take out 2x, leaves us with x minus 9. On the right side, we can take out a 1, leaves us with x minus 9. That's our new common factor. We'll take that out. So x minus 9 times 2x minus plus 1 is equal to 0. And then we'll use our zero product property. So either x minus 9 has got to be equal to 0, or 2x plus 1 has got to be equal to 0. So we'd add 9 to both sides. X is equal to 9, or we'd subtract 1 from both sides, and then we would divide both sides by 2, or so we have negative 1/2. And again, you can plug these in and to verify that those are actually solutions to this equation. Okay. All right. Let's see what we got here. So we'd add 5 to both sides. Got to have everything on one side. So that leaves us with a negative 1. Okay, and then we'd need to do, here a is 8, so we can't use the shortcut. Negative 8x squared adds up to give us 2x. So maybe something like 4x minus 2x. Substitute that in. Okay, and then we'll do our grouping. So here we could take out, no, not an 8, we could take out a 4x, leaves us with 2x plus 1. And here we can take out a negative 1. And what's left would be 2x plus 1. Take that out. What's left? And then we'll use our zero product property. Gosh, I'm going to get that eventually. So either 2x plus 1 has got to be 0, or 4x minus 1 has got to be equal to 0. So we'd subtract 1, and then we'd divide both sides by 2. So x is equal to negative 1/2, or we need to add 1 to both sides, divide both sides by 4. So either x is equal to negative 1/2 or 1/4. All right, I'm hoping this is helping or making sense. I mean, the solving part is fairly straightforward, and if you already know how to factor, then this should be not too bad, okay? If you're struggling with factoring, please again come talk to me. All right, everything's on the left, check. It's in standard form, check. Is there a greatest common factor? Check. So here we can take out an n, leaves us with n minus 7. Okay, so this is already fully factored. We don't need to do glasses, okay? We only need to do glasses if we end up having an n squared. And if you wanted to, I think you could probably do glasses with that, maybe. But GCF first is best, okay? So here is a note here. A variable by itself is always going to, like our solution there will be 0. A variable by itself gives us a 0 solution. Okay, so for example here we have our, this is basically a parenthesis. Okay, so either this has got to be 0 or n minus 7 has got to be 0. All right, so we already have that one done. We just add 7 to both sides. So either n is equal to 0 or 7. Okay, and again, you can plug that into your original equation. Let's just do that. So we could plug n is 0, so 0 squared minus 7 times 0. Well, yes, that does give you 0. 0 minus 0 is 0. Check. Or we could plug in 7. So 7 squared minus 7 times 7 is equal to 0. Well, that gives us 49 minus 49 is equal to 0. Okay, so you can check that. We're good. I think I missed this one here. Okay. Oh yeah, the GCF does not affect, or is it affect? Affect, I can never remember. Does not affect the solutions. Okay, so like here we factored out, let's see where we had when we factored something out. Like here, we factored out a negative, okay? It doesn't affect your solutions. Is there any others we took out at GCF? No, I don't think so. All right, so yeah, it doesn't matter, okay? So GCFs don't affect your solutions. All right, so here's our last one. Is this our last one? Yes, it's our last one. Okay, so give this a try if you would. Okay. So again, this is the sum of squares. So again, you could use this shortcut. That gives us 2a, and we'll do plus 11. And since it's the sum of squares, we need to put an I. Okay. And then here that would give us 2a minus 11i is equal to 0. All right, so we still use the same zero product property. That's a tie tongue. Okay, so we'd say either 2a plus 11i is equal to 0, or 2a minus 11i has got to be 0. So we would solve for a, so we would subtract 11i. That gives us 2a is equal to negative 11i, and then we divide both sides by 2. So one of the solutions is negative 11i over 2, and then we do the same for the other side. Okay, so here's our two solutions. We'd say a is equal to negative 11i over 2, or positive 11i over 2. Right? Okay, well, if you have any questions, let me know. Again, if you struggle with factoring, please come and talk to me or review our last unit. Thanks.